the differential, might seem complicated at first glance. However, its principle is amazingly simple once understood. Consider two wheels mounted on separate axles and supported by a frame, allowing them to revolve freely at different speeds. By attaching a spoke on the inner end of each axle, we can turn each wheel separately by turning the spokes. Connecting these spokes with a bar or crosspiece, we can turn both wheels in the same direction at the same rate of speed. To keep this setup in place, we use a support that is not locked to the axle but turns freely. This arrangement works fine as long as both wheels can turn at the same speed. However, when going around a corner, this setup does not allow one wheel to drive faster than the other. Stopping one wheel would also stop the other from moving. By putting this bar on a pivot, allowing it to swing in either direction, the bar can still turn both wheels at the same speed. It also allows one wheel to turn even when the other is stopped. However, if turned too far, the bar will swing around and won't drive the wheels effectively. To solve this, we add another crossbar and more spokes. When one wheel is stopped, the crossbars continue to push the spokes of the free wheel, allowing it to turn. As long as both wheels are free to turn, the bars do not swing on their pivot, and the wheels move at the same speed. Adapting this model for use in an automobile requires a few changes. To reduce the jerky action caused by wide spaces between the spokes, we add more spokes. Filling in the spaces between the spokes provides steadier, more continuous action. Changing the shape of the spokes ensures firm, constant contact. Making the gears thicker and stronger, we achieve differential gears that fit together more smoothly and silently. Another gear is added to share the work of driving the axles, maintaining the principle of turning the support to drive the wheels. A large gear connected by a smaller gear to a source of power is fastened at the center line of the differential. Moving the gears closer together makes our model more compact. Integrating the differential into an automobile, we must accommodate the drive shaft, which carries power from the engine. Engineers have devised a way to make cars roomier and closer to the road, without a cumbersome shaft above the floor. The drive shaft is connected to the rear axle at the bottom, making the rear axle quieter, stronger, and more durable. This new low-center drive improves contact between the gears, resulting in a vehicle that is more rugged and reliable, capable of withstanding greater strains, whether on straightaways or around corners.